So this is the algorithm for finding anagrams of string p in string s. So there is a left pointer which is set to 0, right pointer which is set to 0, and there is a map of characters of string p where key is the character of string p and value is the number of times the frequency it appears. So A appears once, B appears once, C appears once. Count is the size of this map, which is 3. The result stores the result of this algorithm. Okay, so we run the right pointer. We run this algorithm as long as the right pointer is lesser than length of string s. We check if the character pointed by right pointer is present in the map. If it is present in the map, we decrement its frequency and increment the right pointer. If the frequency is 0, we decrement count. And this is the logic for moving the right pointer. This is the logic for moving the left pointer. While count is equal to 0, we check if the character pointed by left pointer is present in the map. If it is, we increment the frequency. If the frequency is greater than 0, we increment the count. And then we check, before incrementing the left pointer, we check the size of the window. If the window size is equal to length of p, then we store the result, which is the index pointed by the left pointer. Okay, let's run the algorithm. So r is lesser than 10, lesser than 9. So okay, c is present in the map, so we decrement the count of c and increment the right pointer. Because the count is equal to 0, we decrement count. Because the frequency is equal to 0, we decrement count. Okay, because the count is not equal to 0, we won't increment the left pointer. R is lesser than 9, so B is present in the map, so we decrement the count B. We decrement the count B. And because B's frequency is 0, we also decrement the count. Okay, and increment the right pointer. Because the count is greater than because the count is not equal to 0, we won't increment the left pointer. So R is lesser than 9, so A is present in the map, we decrement its frequency, increment the right pointer. Because the frequency is 0, we decrement the count. Now because the count is equal to 0, we move the left pointer. We check if C is present in the map. If C is present in the map, yes, it is present, so we increment C. We increment value of C because the frequency is greater than 0. We also increment count. At this point, we check the length of the window. Length of the window is 3, which is P's length. So we store the result, which is the index pointed by the left pointer. Now we increment the left pointer. r is lesser than 9, but it is not present in any of the map, so we increment r. Because the count is not equal to 0, we won't process the left pointer. B is present in the map, so we decrement B's frequency and increment R. Because the count didn't change, we are not going to process the left pointer. A is present in the map, we decrease the A's frequency and increment right pointer. Count doesn't change here. Count only changes if the frequency is 0. Okay, so now right pointer is pointing to B. B is present in the map, so we decrement the frequency of B and increment the right pointer. So A is present in the map, so we decrement the frequency of A and increment the right pointer. C is present in the map, so we decrement C, increment right pointer, and because the frequency is 0, we decrement the count to 0. Now because the count is equal to 0, we now process the left pointer. While the count is equal to 0, we check if character pointed by the left pointer B is present in the map. Yes, it is present in the map, so we are going to increment it, but we won't update the count because we will only update count if the frequency is greater than 0. So now we check the length of the window. The length of the window is not equal to P's length, so we won't update the result and we increment the left pointer. A is present in the map, so we increment A's value and we won't update the count. And because the length of the window is not equal to P's length, we won't update the result. We will increment the left pointer. E is not present in the map. The window is not equal to P's length. We won't update the result. We will increment the left pointer. B is present in the map, so we increment the value of B and we check the size of the window. The size of the window is not P's length, so we won't update the result. We also won't update the result. We also won't update the count because to update the count, we need the frequency to be greater than 0. And we increment the left pointer. A is present in the map, so we increment its frequency. We won't update count. We won't update result as the length of the window is not equal to P's length. We'll increment left pointer. Okay, so now B is present in the map, so increment B's value and we increment B's frequency. Because frequency is greater than 0, now we increment the count value and we determine the length of the window. Length of the window right minus left is equal to 3, so which is P's length. So we update the result, which is the index pointed by the left pointer, which is 6, and we increment the left pointer. Now because the count is equal to 1, we are out of this loop, we are back in the main loop. So r is lesser than s dot length is false, so we exit and we return the result 0, 6. So we saw how we moved the sliding window to determine the anagram of string p in S. This because we are passing through the because we are passing through the array once by the right pointer, and at most we can pass right pointer once, we can pass left pointer once. It will be of the order n, where n is the number of characters of string, number of characters in the string S. So it will be, the time complexity will be linear to the length of the string S. That is because the right pointer moves once all the way from start of the string to the end of the string. Left pointer can move all the way from start of the string to the end of the string. So total total number of times you have traversed the string S is 2 times of n, which is linear order n. 2 times n, which is order n. Space complexity it will be the size of the map, or size of the map of P, which is of the order length of P. So space complexity will also be linear to the length of the P.